and you could represent it with area. So what did we do? 12 times 8, we broke the 12 up to 10 and 2, broke our rectangle or our area up into 2 sections, so the multiplying was easy. 10 times 8, 2 times 8, added it up. If we had bigger numbers like 17 times 13, we could break the 17 up to 10 plus 7, the 13 to 10 plus 3, draw our area, figure out each of the sections like a chart, and add them up. This, we made the jump to algebra. And we asked ourselves, what is x plus 3 times x plus 2? And you could, again, draw it as area. This side is x plus 3. This side is x plus 2. Draw the chart or make the area into different sections. X times x is x squared. X times 2 is 2x. X times 3 is 3x. And x 3 times 2 is 6. Then we add them up. But now, when you're adding up algebra, you can only add up like terms. And we get x squared plus 5x plus 6. And then you guys, amazingly, jumped already to like a grade 10, 11, 12 question and did something huge like this one. But you could easily do it with your chart. And we did all of our like terms color-coded here and added them up. No problem. And now we're going to see that when mathematicians do things, they like to try to do things quicker to show less work. I would say if you love the area thing, do it all the time. Because if it makes you not make mistakes, you can do it on scrap paper, you can do it off to the side. But mathematicians noticed that when we wrote the area, what was happening is that the x multiplied the x, which you could show with an arrow. That the x multiplied by the 2, you could show with an arrow. The 3 multiplied by the x, which you could show with an arrow. And the 3 multiplied by the 2. And they even came up with a way of describing this. And that's where we'll get to our notes. Come on. And now it froze, of course. Wonderful. As everybody groaned in class, like, oh, now we'll get to our notes. Did someone mentally force the smartboard to freeze? Oh. Unbelievable. This is a good thing. There we go. We're back. Okay. Here it's working again, and don't worry, it's not working fast. There we go. As soon as I push a button, it starts to unwork. Okay, we'll try to shut some things down to see if that works. Here we go. We're working again. Yes, at the end of this book, we'll have a test. We'll also have another quiz. We should have a quiz probably pretty soon. When do you want a quiz? That's a good idea. Quiz on Wednesday.
No, that's in the middle of the week.
Monday?
No.
Tuesday. All right. No, Thursday's too long. We'll have a quiz on Tuesday.
Wednesday. I say Wednesday right in the middle of the week.
I know. An hour will be long enough for a quiz.
No, do Wednesday, please.
Wednesday?
Yes. See, Haley. Why should I?
You want a quiz right now? Okay. Okay, we'll have our quiz on Wednesday. Okay. So, The arrow thing, which is related to your area, right? Again, you can always use your area, x minus 2, x plus 4. The area thing even works with minuses. Okay? This would be x squared. This would be 4x. This would be minus 2x. And this would be minus 8 when you multiply with the negatives. Yes? Okay. The mathematicians use the area, and with the area, they even labeled these arrows. I'm going to color code them so that you can really see. They draw this first arrow, and they say, hey, that's your first ones multiplied together. We'll use the word F. Then this arrow, those are your outside ones. We could use the word O. Then this arrow, those are your inside ones. Either one. Again, once you do more mathematics, you'll probably use the arrows because it takes less space. But I like the chart because I think it makes more sense. Helps you understand it. So if you're doing the arrows but have the chart in your head and saying, I could do this with the chart, but the arrows are faster, awesome. If you're doing the arrows and you have like, I have no idea what to do, I just draw these arrows, then I'd say go back to the chart because you want to know why it's working. So if you multiplied your first ones, you would get x squared. If you multiply your last ones, then you would get plus 4x. Your inside ones, this is where you would get minus 2x. And your last ones, this is where you would get minus 8. So you see how I color-coded it? By your first ones multiplied together, your outside ones multiplied together, your inside ones multiplied together, and your last ones multiplied together, making the word FOIL. Okay, so you'll often hear teachers say, oh, you just FOIL. It's not actually a mathematical thing. It's just an acronym that helps you remember what you need to do. But again, I like the chart the best for understanding. Then your final answer here, you have these as like terms. So your final answer will be x squared plus 2x minus 8. Hey, you know what's really cool with the minuses? Is the minuses work with numbers. Now, I wouldn't recommend this, but check this out. Did you know that 2 times 3 is the same as 10 minus 8 times 10 minus 7? And so you can make an area with a 10 and a minus 7, a 10 and a minus 8, and split it up and get 100 minus 70 minus 80, and then minus 7 plus 56, and add all those numbers together and get 6. A little bit counterproductive, but cool that it works. Would you agree? Because this would be 100 minus 150. You're at minus 50. Then you add 56, and you're back to 6 again. Right? You can now show your parents that you could do 1 times 1 by making it 100 minus 80 minus 19 times y. Yeah. And then for sure they would say your math teacher is crazy because they would say, you mean you're not supposed to just do 1 times 1 equals 1? What are they teaching you in math these days? Anyways, so it just shows that negative numbers work. All right. Choose chart method or arrows or both. Why don't you do both for these? Which one are you going to? You're going to the arrow still, or are you going to the chart still?
I mean, for like now, it's easier to try the arrow.
Because now that you know how both of them work, that they're the same. Okay? Try these. Arrows and chart. Where are your notes? Oh, man. So try these, either with the chart or with the arrow. Yeah. Try these. You don't want to do the chart. You make a little chart. Yes. No, you don't need the plus sign. I just. So if I was using the arrows, the first one's blue, that'll be y times y, that's y squared. Then the outside ones are y times 9, that would be plus 9y. Inside ones, minus 6y. Last ones, minus 54. I'm color coding it right now so you can really see first, outside, inside, last. We can write above here, first, outside, inside, last. Then I have what often happens when you FOIL, especially when the first ones are the same and the last ones are numbers, that the middle always matches up. And so our final answer here will be y squared. These can get combined because they are like terms. And there's our final answer. And if you want to, if you're finding this, you're understanding it's good, if you want to push yourself, once you get your answer, right, could you get back to the original question? That's going to be like the next level of thinking. That's almost all of grade 10, 11, and 12 really uses this idea of breaking it back to what it was originally. And if you want that challenge, what I would suggest, you want to challenge yourself, just make up random ones with x's and numbers, x plus something, x minus something, x plus something else, x plus something else, x minus something, x minus something. Make about 5 of them. Multiply them all out, get the answers. Put the answers on a separate piece of paper, watch your favorite Netflix show. Okay? Crumple up and burn the original paper so you don't have what it was originally and you can't cheat. Don't light a fire in your house, though. Okay? Maybe just throw it away and put spaghetti sauce, something you won't want to touch, instead of burning it. Okay? Then see if you can figure out what they were originally. And that is challenging, even if you made them yourself. Oh. Okay. Second one. All right? Got your chart. You can do m and 5, m and minus 12. You could, yes. Yes. Okay? chart method, this is what you would have in each of these. Arrow method, first ones, outside ones, inside ones, last ones. M squared, first ones, minus 12m, outside ones, plus 5, oops, the wrong color, plus 5m, inside ones, and minus 16, last ones. Once again, surprise, surprise, only the middle ones are like terms. And we get as an answer m squared minus 7m's minus 60. Okay? Whew. Okay. Oh, I just want to have fun. I'm going to give you one. I'm going to give you one as a challenge. It's you've done easy. This is you're seeing it, you're getting it. Yes, you need more practice, but I think you're understanding it. Now I'm going to give you the challenge. Okay? I'm going to give you the challenge that you have x squared. How hard of a challenge should I do? Not too hard, not too hard. Not too hard. Not too hard. Here we go. Here's your rectangle. Here's your 4 spots. This is the answer. Which of those spots can you fill in for me already? The 24 would have to be here, right? The x squared would have to be here. That also tells you what these are. X's and X's. But it doesn't tell you what's there. Why? Because it could be many different options.
It could be 6 and 4, 5 and 5.
No, 5 times 5 doesn't equal 24. But 6 and 4 or 12 and 2 or 1 and 24. You have different options. Okay? So let's say you picked 12 and 2. Okay, let's say you picked 12 and 2. What's the problem with 12 and 2? Doesn't add to 10. So we should make that go away. All right?
Yeah, I'm a little confused on that.
But if you did 6 and 4, then this would be 6x and 4x. Does that work?
Yes.
So you now know it's x plus 6, x plus 4. Okay?
Wait, how did you do that then?
What do you mean? It's enough wind. Okay? Oh, but you know what? I made a mistake in my original question. I'm so sorry, guys. That was a minus. You have to still figure it out. By the way, if you now did 6 and 4,
What if you just had a negative one?
does it make negative 10? No. So we have to,
You're doing the wrong one.
that one didn't work.
Wait, I'm actually so confused though. I'm a little confused.
Yeah, it's crazy.
Make them reappear.
Make them reappear. Can't make them reappear. Right? To get a minus, right? Make them both negative? Negative 12 and negative 2. Let's try that. Yeah, negative 12 and negative 2. That'll make negative 12x and, oh, but that would make negative 14.
He has like a button or something.
I'm not pushing. Wait. Oh, I thought you had the answer. No?
But then how does the time
Well, tell me the answer, then you can go to the washroom. 12 and 2? Okay. Now, this is good. I like this. He says negative 12 and 2. What's wrong? It makes the 10, but it doesn't make that. It makes now a negative 24, and we need a positive 24. Minus 6 and minus 4, this would give me minus 6x. This would give me minus 4x. It still gives me plus 24. X minus 4, x minus 6. Do you have the answer for this one? What is it? Yeah, okay, for sure. Go ahead. All right, sorry. So this is where we're going to. You like my pen that just erases on its own? Yeah. Here is a next challenge one. We're multiplying 3 things. You have to go back and ask yourself, how do you multiply 3 numbers? Can you do 2 times 3 times 4? What would you do if you had 2 times 3 times 4? You get 24. What did you do first? You chose 2 of them to multiply first, got 6, and then 6 times 4, you got 24. And some of you did in your head, you didn't even realize you multiplied 2 of them first. Same thing here. We choose multiply these ones first. How do you multiply with the number out in front? Multiply that first. And then, now you can either make your chart or you can multiply your first ones, your outside ones, your inside ones, and your last ones. I used that color already. Yes, you can choose whichever 2 you want to multiply first. For example, if I did 2 times 3 times 4 and did the blue first, I would get 2 times 12. And then I get 24 that way too. So Nevaeh said she foiled these 2 first, multiplied them out, and then multiplied by 2. That's perfectly fine. Nevaeh did, see, I multiplied the blue ones first, underlined in blue, and now I'm going to FOIL. Let me finish it. 2x times x, 2x squared. I should write that in black because I like to color code things. That would be 2x squared because that's my first ones. Then my outside ones, 2x times 2 is plus 4x. That's my outside ones. My inside ones would be minus 6x. And my last ones are minus 12. And my final answer is going to be 2x squared. These are like terms, minus 2x minus 12. And again, next year in grade 10, you're going to be asked to go backwards and write that.
That was impressive going from the green to the red to the blue as fast as you did.
I work on it. I work on it. Okay?
No, I think it's amazing.
So. Now, should I? So I will, because it was bothering you, I will describe what I did with the blue pen. My hand waving had nothing to do. I have a timer, so I set up a special pen here in the top right-hand corner. When I click on that, that pen, I've designed it so it has a color and that it fades out after 6 seconds. I can change the time.
And it had to be the color that you chose.
Well, I can change it, like if I want my disappearing color to be a different color, I could save it as a new color. So now I have 6 seconds before things disappear. Ooh, wizardry, right? No, just special for you guys. You're the only special class. Right? There is, under Creative Pen, this is where I got the idea. Of course, the Creative Pen, when you click on it, sometimes makes the whole smartboard freeze.
Actually?
Well, what's it doing?
I thought it was actually a thing.
No, not the Creative Pen. It's there's a Magic Pen. It's an option. The Magic Pen erases just like the other one erases, which sometimes takes long to get there. It's going to erase eventually. There it goes. Okay? The Magic Pen also allows me to highlight certain things, like I want you to look at the number 12. It didn't work. Usually it works.
I think you should connect the circle.
I tried. It's supposed to go all black and just show that. But maybe it is not so magic anymore. Yeah. Anyways, that's where we'll end for today. Oh, it erased wonderfully.